Hello, this is Professor Werwath. I want to talk about an interesting and kind of subtle topic that affects mostly the software community, but I think it also impacts hardware as well. And the topic is managing technical debt. You'll see in a moment what we're talking about with technical debt, but you can think of it as the embedded base of defects and deficiencies that are buried in your code or your product that winds up being inherited by future iterations and designs built on that product. So, and potentially even impacting your own product development schedules and resources. And so, in my mind, I guess a lot of where this mentality starts with is the relatively recent, I'd say the last maybe 15 years or so, phenomenon that comes from the Zuckerbergs of the world that profess that we should be moving fast and breaking things, and that's great unless you're the guy who has to fix it, right? Unless that brokenness keeps you from shipping product, or that brokenness has disappointed a customer, or in a mission critical situation, maybe even cost somebody their life. So breaking things is great if you're an entrepreneur and you want to break the rules and see what can be done instead of what's always been done. But products are a little bit different, right? An established product from an established company, it has to meet certain standards of quality, certain standards of reliability, right? The threat here is that if you're not moving fast enough and breaking things, you're not moving fast enough, period, right? And the moving fast means, by definition, that you're breaking things. So what are the consequences, right? One consequence is you increase your technical debt. So technical debt refers to the implied cost of additional rework that arises when software that is easy to implement in the short run is chosen over solutions that may be more difficult but are easier to maintain in the long run. Okay, so it's short-term versus long-term thinking. This constant stress and focus on short-term thinking can be disastrous for any organization and any culture, right? If you're thinking about optimizing the next 48 hours instead of the next 48 years, you're going to act very differently. And that difference will eventually bite you, and bite you in terms of cost, in terms of risk, in terms of schedule in the future, right? Significance, right? In software development, technical debt can accumulate over time, almost like an avalanche of sorts that keeps getting builds bigger and bigger as it rolls down the hill, right? And unfortunately, the people at the bottom of the hill catch the majority of the pain. So you need to basically give proper attention to maintainability and code quality. It can slow down development, increase the likelihood of bugs, and reduce the efficiency of future updates or modifications. So these deficiencies have a price. That's the point, right? Understanding technical debt is crucial for project managers and project developers, and I would argue as well, engineering managers, stakeholders that are also impacted because it impacts stability, scalability, success of the software projects, time to market. Your schedules are impacted, right? If you have a certain defect density in your code base, and that is higher than it should be, that will elongate your schedules. And that may disappoint your customers. It may miss your target market window. It may have a whole lot of implications, especially cost and resource, right? Customer satisfaction is impacted, as well as long-term viability. If you have too much technical debt and it becomes unmaintainable, your reputation suffers and your company is basically at risk. So there's three types of debt. I could add a fourth one at the end, but let me just start with these three: testing debt, design debt, and code debt, right? Testing debt arises when testing activities are postponed, right? So you have different types of tests. You have new feature tests, you have systems tests, and you have regression tests, right? Often it's the regression tests that are postponed, right? And what that means is the side effects of what you're doing on the new code side is not well understood, and you're pushing that into the future. You're pushing that lack of information, that deficiency into the future, and somebody's going to have to pay that price, right? Automated testing is inadequate, leading to undetected bugs, poor product quality, difficulties in regression and continuous integration. So I would argue that this increases the risk of deploying product into the field. So with testing debt, you're pushing the risk into the market, okay? The risk of failure, the risk of defects, the risk of deficiencies in performance, right? Design debt refers to compromises or shortcuts taken in the system architecture or design that may lead to inefficiencies, limitations in scalability, or increased complexity over time, affecting long-term maintainability and extensibility. In my mind, this increases the cost and risk of future developments. So whereas testing debt is a deployment risk, design debt is a development risk, right? Or for the future. Code debt is incurred when developers take shortcuts and use quick fixes or neglect best coding practices, resulting in messy, hard to read code that is prone to errors and challenges in future code maintenance and updates. This increases the risk of of current development. So the code debt that you're incurring today is a price you're likely to have to pay in the very short term. Okay, so this is very, I guess, short-term focused, and in many ways, kind of foolhardy to take shortcuts in your code today when you literally will have to pay the price as early as tomorrow. So what's the impact, right? Accumulating technical debt can result in increased project costs, delays in delivery timelines, decreased team morale, potential project failures due to the compounding effects of unresolved issues, reduced productivity, and escalated maintenance efforts. The team effects, right, can lead to frustration, burnout, decreased creativity, negative impact on collaboration. It can hinder innovation. And as you'll see later, there's kind of a tension between dealing with that and dealing with innovation, right? And you're going to have to, as a manager, especially as you climb the ladder, you're going to be allocating resources between innovation and debt resolution, right? And it can also impede the adoption of new technologies and practices. Oftentimes, platforms get so bogged down in their own debt that the only answer is to go to a new platform and to basically abandon the old code base and to start afresh, right? But it doesn't make sense to start afresh if all you're going to do is incur technical debt on a new platform. What are the business implications, right? Technical debt, again, can harm customer satisfaction, reputation, competitive advantage, the inability to adapt quickly or deliver high-quality solutions, lost opportunities, increased support costs, and decreased market share. So this is an insidious problem that often doesn't get discussed. And I think, frankly, it needs to be discussed on an open basis, right? How much debt have you added or subtracted during the course of your project? What are you pushing into the future? What goals have you set as a project manager? Have you set for resolving technical debt and reducing technical debt during the course of your project, right? It's not enough to say, well, the new features didn't make it any worse. If you've got buggy code, you should strive to make it better and less buggy over time. So resolving previous debt, previously incurred debt, as well as producing good quality code that will not increase the debt in the future. So what are the strategies? What do you actually do here to keep this from happening and stopping or reducing your technical debt? First and foremost is prevention, right? Enforce coding standards and code reviews, promote continuous integration to reduce the accumulation of technical debt, right? In terms of identification, regularly assessing code complexity, technical debt metrics, and conducting debt sprint planning to prioritize and address high impact areas. So the debt is just as important as the new features in some cases, right? Meaning it's got to be scheduled and planned just like the new features and the new capabilities that you're putting into your project. Mitigation, invest time in refactoring code. I know nobody wants to talk about it, and it almost becomes a little bit, scary or insurmountable. But in some cases, without making that investment now, you're going to pay a much heavier price later. Automated testing helps you get through testing debt, so you can actually get through the testing regime faster and more completely, right? Technical debt payback sprints to systematically reduce existing debt. So put this into your sprint planning, put this into your agile approach. So it's not just the new features that you're scheduling, right? In terms of monitoring, utilize tools like static code analyzers, maintainability indexes, and technical debt dashboards. So track your technical debt, make sure it's visual, so visualize the trends, and make informed decisions about debt management, what you can and can't do, what you will and won't do. And at some point, the piper has to be paid. In terms of case studies, right, successful management can result in 60% reduction in bugs and 40% increase in speed and a 25% improvement in team satisfaction. When you're unsuccessful, when you do this poorly, right, you'll see a 40% increase in post-release defects, 30% decrease in deployment frequency, because you're getting bogged down, right? 20% rise in unplanned work and negatively impacting project outcomes and team efficiency. So all the more reason to, manage technical debt properly, right? A recent article in CNBC talked about technical debt and how companies like Adobe, we saw Adobe in the previous slide, right? Adobe and others are reframing technical debt as an opportunity to bring into their iteration process, right? The technical debt resolution, right? 70% of organizations' ability to innovate is being hampered by technical debt, right? What does that mean? I use the tug of war example, right? So you've got two fundamental tensions, right? The need to address the debt and the need to innovate. And you have to strike a balance, whether that's 30% debt and 70% innovation, or in mature companies that have a huge legacy base, that could be flipped, where you're spending 70% of your time addressing debt and 30% innovating. That would be a shame, and that is an indication that either a new platform is needed or a total refactoring of the platforms you have. If you look at Apple, for example, they were more than willing to abandon old CPUs, such as the Motorola CPU in favor of Intel, and Intel in favor of their M1, M2 class CPUs. And along with it, the code base and all the technical debt that goes with it. They were also willing to change the source code. Next replaced the old source code, and Linux replaced Next. So you wind up with a progression of platform shifts and changes as a way of absolving yourself of previous technical debt and moving forward with something that's a little bit more pristine. So what are the key takeaways? Prioritize technical debt management as an integral part of software development. Implement a culture of quality, and I'll emphasize that: quality, transparency, and continuous improvement to prevent excessive debt accumulation and ensure long-term project success, right? In conclusion, effective management of technical debt is essential for delivering high-quality software products, maintaining morale, and meeting project deadlines. By proactively managing debt through strategic planning, continuous monitoring, and targeted actions, organizations can optimize their software development processes and achieve greater success. To do this, the recommendation is engage in regular code refactoring, adopt agile practices, foster collaboration between development and operations to address debt incrementally, and foster innovation and maintain a sustainable software ecosystem. In other words, don't ignore the debt, right? Manage the debt, deal with the debt, put it in your project plans, and recognize that as the debt accumulates, the innovation capacity goes down, right? Whether you plan for it or not. So with that, I want to thank you all and let you discuss technical debt amongst yourselves.